In this module, we will study about forces, effects of forces, extension of spring and friction. Learning objectives. Inertia and mass in terms of inertia. Inertial mass. Forces. Newton's laws of motion. Momentum. Weight and stretching. Hooke's law. Friction. Terminal velocity. Inertia. Inertia is the property of a body to resist change in its state of rest, state of motion, or direction of motion. There are two types of inertia, inertia of rest and inertia of motion. The inertia of rest is the property of a body to resist change in its state of rest. Inertia of motion is the tendency of a body to resist change in motion when the object is already in motion. So, if the object is at rest, it always stays at rest, and if the object is in motion, always moves at constant speed in a straight line. We can observe inertia of rest in day-to-day life. If an object is at rest, it remains in that state. But it is difficult to observe inertia of motion. Earth attracts all objects towards its center. So if you throw an object with a velocity, then due to gravitational force of Earth, it will fall to the ground. But if there is no gravitational force by Earth, or if there is no gravitational force by Sun and other planets, if you throw an object into space, it will continue that state of motion along the straight path. We can see some examples for inertia of rest. In the first picture, you can see a glass, then a cardboard and a coin. If you strike the cardboard will fall, but the coin will remain in its state of rest due to inertia. As a result, it will fall to the glass. Now you can see in the second picture, bottom, a person standing inside a bus. If this driver suddenly starts that bus, then the lower part of his body is touching the ground, so it will move forward along with the bus. But the upper part of the body have some tendency to remain in its state of rest, so his upper part will fall backward. So he is using one handle here, otherwise he will fall down. Now you can see another picture, a person trying to shake one tree. So when he shakes the branches will move, but the fruits will try to remain in its state of rest. As a result, it will detach from the branches. Now in the last picture, we can see a pile of carom coins. If you strike the lower coin, then it will detach from that pile of coins and the remaining coins will stay there. This is due to inertia of rest of that pile of carom coins. Inertia of motion. A person sitting inside a vehicle possesses inertia of motion. So if the vehicle or if the car suddenly stops, then lower part of his body will come to rest, but the upper part possesses a tendency to remain in its state of motion. So that can cause accidents. So that is why we have to use seat belt. Now the same thing happened inside a person standing inside a bus. If a fast moving bus suddenly stops, then his lower part will come to rest along with the bus, but the upper part of his body has some tendency to continue in its state of motion. As a result, he will fall forward. Mass in terms of inertia. The more inertia that an object has, the more mass that it has. A more massive object has a greater tendency to resist changes in its state of rest or state of motion. So, Inertia of rest or inertia of motion increases with mass of the object. So we can represent mass in terms of this inertia. An object at rest remains in its state of rest, and an object in motion remains in its state of motion. So what can a force do? Force can change state of rest. Force can stop a moving object. It can increase velocity of an object and decrease velocity of an object. Force can change direction of motion of an object. It can increase the volume or decrease the volume of an object. It can change the shape of object. So force is something that can make any changes in one of these factors. Force. In science, force is the push or pull on an object with mass that causes it into change velocity. Force represents as a vector, which means it has both magnitude and direction. In equations and diagrams, a force is usually denoted by the symbol F. Unit of force is Newton. A force is required to change the state of rest or state of motion. But there is a condition. This force should be an external force and it should be an unbalanced force. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by an unbalanced external force. You can see one example for balanced forces. Here is a block and two people pushing that block. If they apply the same force in opposite direction, then there will be no net movement. And you can see an internal force, a person sitting on a chair, without touching any part, he cannot or she cannot move that chair because the force is internal. If you want to move a car, first we have to come out of the car and push. If you sit inside the car and trying to move, it is not going to move. So an unbalanced external force is required for the movement of objects. The acceleration of an object is proportional to force. Force equals mass times acceleration. That is, F is equal to ma. Unit of force equals kilogram meter per second square. It is also called Newton. So Newton is the unit of force. Weight is also a force. Weight W equals mass times acceleration due to gravity. That is, W equals mg. 1 Newton is defined as a force which will give a 1 kilogram mass an acceleration of 1 meter per second square in the direction of the force. Let us discuss another property of moving object, momentum. Momentum is the property of a moving body. Momentum is the product of mass and velocity of an object. It is given by the expression P equals mass times velocity. P is the momentum, mass is m and velocity is v. Mass is a scalar quantity, but velocity is a vector quantity. So momentum is a vector quantity because it is the product of a number and a vector. Momentum increases with mass. You can see a bicycle and a moving train. Even if they possess the same velocity, the train possesses more momentum because of mass. Now in the bottom you can see a boy throwing a stone and a bullet firing from a gun. Even though the mass of the bullet is very small, the velocity is very high, so it possesses more momentum. Momentum of a body related to force. Mass of an object is constant. We can change velocity by applying force. Momentum P is equal to mass times velocity. Change in velocity causes change in momentum. Consider an object of mass m moving with velocity v1. The momentum p1 is given by p1 is equal to mass times velocity. A force F can change its velocity to V2. Therefore, P2 equals mass times V2. So, mv1 is the first momentum and mv2 is the second momentum. Now, change in momentum is P2 minus P1. That is mv2 minus mv1 equals m into v2 minus v1. Rate of change of momentum, that is momentum divided by time. That is m into v2 minus v1 divided by time. But we know change in velocity with respect to time is acceleration. So that is ma. So rate of change of momentum is proportional to force, or F is equal to ma. If more than one force is acting on an object, we have to find out the resultant of forces. So in the upper picture you can see 1 Newton force and 2 Newton forces acting along the same line. So the resultant is 3 Newton. Now in the second picture bottom you can see 2 Newton force acting towards left and 3 Newton force acting towards right. So the resultant force is 3 minus 2 equals 1 Newton. We know that force is related to momentum of a body. So that is Newton's second law of motion. Newton's second law of motion states that the time rate of change of momentum is equal to the force acting on the particle. Force is equal to rate of change of momentum. Force equals mass times rate of change of velocity, or that is force is equal to mass into acceleration. F is equal to ma. Newton's third law of motion. Whenever one body exerts a force on another, the second body exerts an equal and opposite forces on the first. That is, to every action there is an equal and opposite reaction. If air is removed from a balloon, the balloon moves forward and air moves backward. So this is due to Newton's third law of motion. If one ball is thrown to the surface, the ball exerts a force on the ground. That's an action, but due to the reaction force, the ball bounces back. Let us see another application of force, weight and stretching. Extension happens when an object increases in length, and compression happens when it decreases in length. A spring can be extended using a force. The extension produced on a spring is proportional to the mass attached at the lower end of the spring. Extension is proportional to applied force. That is, extension is proportional to weight. The applied force causes a deformation. A restoring force developed in spring to bring it back to the original state. If we add more mass to the lower end of the spring, there will be more extension. Within certain limits, the force required to stretch an elastic object such as a metal spring is directly proportional to the extension of the spring. This is known as Hooke's law. That is, F equals kx, where F is the applied force, x is the length of extension or compression, and k is a constant of proportionality known as the spring constant, which is usually given in Newton per meter. The restoring force developing in the spring is in the opposite direction to the force which causes the displacement. Pulling down on a spring will cause an extension of the spring downward, which will in turn result in an upward force due to the spring. When calculating x, it is important to remember that the spring itself will also have some nominal length L0. The total length L of a spring under extension is equal to the nominal length plus the extension. That is, L is equal to L0 plus x. We can see the graph showing stretching force along the y-axis and total extension along the x-axis. From 0 to E, it is directly proportional. That is, it is within the elastic limit. After the point E, even without adding much forces, the extension is happening, and at the point A, it completely loses the elastic nature. It may either break or it will lose the elastic property. Let us solve one problem. A spring is stretched 10 mm by a weight of 2 Newton. Calculate the force constant K, or the spring constant. The weight W of an object that causes an extension of 80 millimeter. So we know the expression F is equal to K times X. So spring constant K is equal to F divided by X. So that is 200 Newton per meter. Now W is equal to stretching force. F is equal to K times X. That is 16 Newton. Let us study another type of force called friction. Friction is defined as the force that opposes the motion of a solid object over another. There are different types of friction: static friction, sliding friction, rolling friction, and fluid friction. Static friction. Static friction is defined as the frictional force that acts between the surfaces when they are at rest with respect to each other. The magnitude of the static force is equal in the opposite direction when a small amount of force is applied. When the force increases, at some point, maximum static friction is reached. Maximum value of static friction is called limiting friction. After that, the object moves. Sliding friction is defined as the resistance that is created between any two objects when they are sliding against each other. Rolling friction is defined as the force which resists the motion of a ball or wheel and is the weakest type of friction. Fluid friction is defined as the friction that exists between the layers of the fluid when they are moving relative to each other. You can see a spring balance attached to a block. When a gradually increasing force P is applied through a spring balance to a block on a table, the block does not move at first. This is because an equally increasing but opposing frictional force F acts where the block and table touch. At any instant, P and F are equal and opposite. If P is increased further, the block eventually moves. As it does so, F has its maximum value called the starting or static friction. When the block is moving at a steady speed, the balance reading is slightly less than that for starting friction. Sliding or dynamic friction is therefore less than starting or static friction. Another example for forces in action is during the free fall object. Friction in air and terminal velocity. Terminal velocity is the maximum velocity attainable by an object as it falls through a fluid. It occurs when the sum of the drag force is equal to the downward force of gravity acting on the object. Since the net force on the object is zero, the object has zero acceleration. There are three stages for a falling body. At the start, the object accelerates downward due to the force of gravity. As the object speed increases, frictional forces such as air resistance or drag increases because more fluid molecules are getting pushed out of the way. At terminal velocity, the weight of the object due to gravity is balanced by the frictional forces and the object falls down with constant velocity. If you like this video, please share and subscribe. If you have any question or suggestion, please type in the comment section. Thank you.